So I will try to upload soon for the source code at least version 1 and then version 2. So version 2, how version 2 different from version 1? Actually, we have this one. Event. Originally, we should have here 4 means 0, 1, 2, and 3. So we have the actual 1, 3. 3 means stop simulation. The event to stop simulation. And also look at these. I try to draw your attention to look at these. Plus 1. Here me plus 1. Why plus 1? Because of 0. We start from 1, but, we start from 1, but C programming language allows the index for array starting from 0. So that's why we have the size plus 1. Alright, and here, next event, we have 4 says 0, 1, 2, and 3. 3 says start simulation. Alright, so we should start simulation. As for the others, the same. Alright. Therefore, this one, fixed run length. And here, maybe somewhat smaller, but look at these, do. Previously, we have a while, but this time it's do. And while. While says next event time equal to, while next event time not equal to 3, not stop simulation, then run and run and run. So initially, of course, we can do because stop simulation, it won't be the first event. So we can get it, check it, get it, check it, get it, check it. So once it's 3, then we should stop. Alright, so when we have a stop simulation, we have 3. Alright, if we have a stop simulation, then we will stop it. Well, up to now, where we set stop simulation. Well, we set the stop simulation. First of all, here. End time. You will have the in file, but the time in file, you will have interval time, you will have mean service time, and you will have end time. Then it is not the sample size, it's end time. End time says when to stop simulation. Alright. And initialization. Here we have these, but we have type 3. Type 3 is scheduled for the end time. So look at this. We have this one. This is the actual one. Alright, the actual one. We set the end time. This is the actual one. So let me move back to this one. End time and start simulation. You see, right? Here we have 4 because of actual event, stop simulation or end simulation. To end simulation, we change the number event and we have the file to key time to stop simulation. and we change while, we use do while. Okay, and we have 3 to denote start simulation. And to start simulation, we need to have time for event 3. Event 3 is end simulation, you see. So, it's still all the same. Right? It's still the same, but we will have the output here. Same and same. Alright, so this one the same. However, this one you should key in. So you should key in the in file. How long? We have 480 here, minutes. About minutes, maybe not minutes, it's second, or maybe you change time unit to anyone because it's a virtual one. Alright, it's a virtual one. Well, up to now we have 2 simulations, right? And let me share this one for you. Mean inter-arrival time and mean service time. Currently, the setting here is easier. Inter-arrival time longer. Mean service time shorter. Right? Likewise, same. Mean inter-arrival time longer. Mean service time shorter. Let me ask you this question. How about exchange the 2 values? Mean inter-arrival time is 0.5. Mean service time is 1. Is it okay? So let me ask you this question. Mean inter-arrival time and mean service time here is changed. And then, is it okay? If it is not okay, why? Or maybe it is okay, same, why? Then you have 2 minutes to discuss with your neighbors. Guess what? Okay or not okay? So let me check. Anyone want to let me know okay or not okay?
Not okay.
It's okay or not okay?
Not okay.
Not okay from group 4. Not okay. And how about the other groups? Okay or not okay? It doesn't mean very good. I mean, current exchange. It is okay or not okay?
Oh, no.
Not okay? Alright. Group 1, not okay as well. It doesn't mean group 1, not okay. Answer from group 1, not okay for the exchange. And the group 2?
Not okay.
Not okay. And the group 3? Not okay. That's correct. Why? Anyone want to let me know why? Speak louder.
We can take a example for bus arrival, like first bus for 3 minutes and the second one for 7 minutes. So mean is 5 minutes. But if we have each bus 5 minutes arrival, that will be mean 5 minutes again. But the difference will be on the variance. The bigger the variance, the worse. Usually, in theory, it will cause the unstability in the system.
So about the reason here, acceptable or not? Maybe let me see one more. One of you say digestion. That's a good reason. So let us know.
So,
Speak out.
so
I think there's like if the guest arrive for 1 minute and for half a minute for one customer, but we service them for 1 minute, then each customer will wait for like half a minute maximum, not exactly but maximum. So like most customer will wait until they can get service, and that's wait time may accumulates for customer come later. Yeah.
So the key term
Key term.
can digest or cannot digest the
Cannot digest
yeah.
or handle. I don't know if digest or handle is the right word.
I think using the term of digestion is good. Here, I'm a guy to eat. You serve me a lot of food, but I cannot eat anymore because I eat slow. I eat slow, right? So coming soon, but I eat slow. So I cannot digest anymore. So finally, you will give up even I pay. But sorry, I cannot eat anymore. So this is a good way to let it know. Even you don't have the concept of queuing theory. So that's why I think I heard one good term, digestion. Oh, okay, cannot be digested, so that's a good reason. All right. So, okay for the other members. About cannot digest, and so that we use this reason. So, cannot be exchanged. That says coming late. Serve soon. Alright, for me, I can change it to a new one. Here we have the mean interval time and we have the mean service time. Actually, we can use 1 over mean inter-arrival time to denote arrival rate. And 1 over mean service time to denote service rate. So here, if I have a larger service rate and smaller arrival rate, then I can digest all the something like the food here. Alright, so using 1 over the mean value, 1 over the mean value. Then we can have the interpretation. Service rate and arrival rate. Of course, you need to guarantee the service rate is always larger than the arrival rate. And then this is a stable condition. All right, so we guarantee the stable condition. If you want to violate the stability condition, then you cannot have the stable result. So, you cannot have the stable result. What it means? You can run the simulation, and you can try. You can try to have the simulation to exchange the value. And try, for example, try to use version 1 or version 2. Version 1 says 100, you can try to have 200, you can have 1,000. Then you can check the statistic. Can you have the stable result? Finally, no. No. Yes. Because you have more, and then it depends on the number of customers. We have the different, for example, queue delay. 100, then 100 delay. 1,000, then for 100 and 1 to 100 for those customers, maybe delay longer than the delay for the first 100 customers. So getting larger, getting larger, getting larger. You cannot have the stable results. All right. So you cannot exchange the two values. Finally, mean interrupt time longer than the mean service time, or using the service rate. Service rate should be greater than the arrival rate. About the, actually, I call it the conclusion for the parameter setting. Is it okay for all of you? All right, so keep in mind, otherwise you will have a problem. Your simulation result cannot reach the stable results. All right, that's it. It's really important. So, actually, maybe you have a question. Why we have these? In fact, if I have the proper setting, then I can show you the whole article content immediately. But in the past, I tried several times. Sometimes I cannot have the proper setting, so I use the source code. The current problem here, regarding the source code discussed, try to point out where you don't understand where. If no, okay, just type no. All right, so here, maybe it's your first time, you can scan the QR code. But at least, if you cannot have the proper setting, possibly name on screen using student ID and name. And so that it will be easier for TA to collect. And this is a third week. So of course, we can collect the statistic for you. It's a point for your activity. Screen name using your student ID and name. Okay, nothing or no? Yeah, for not yet, you can check it later and so that, oh, okay, you think, you understand, oh. So let me have time of 1 minute. I forgot to set, so you have one more. All right, so let me check. Anyone up to now not finished? Okay, where for you? You need to join. This is the activity, and I will collect the points to that you have the points of activity. And the current point 2 points for the poll. Yeah, for not yet, for not sure, you can check it later. And of course, I can that you have the source code, and of course, you can check the PPT slide to check your comprehension or not. All right, that's fine. Actually, oh, not this one. Printing name for the system. For the system, not here. Maybe you think it's okay, but not this one. Not sure, that's great. Because it's true fact of you, so it's okay, not sure. And not yet, okay. Not yet to exam, so I mean to exam the detail, that's okay. So sometimes you don't want to pretend. No, you can use the terms, that's okay. Because it's true for you. All right, and actually, TA will collect the points for you, so we should know who you are. So of course, you should let us know the student ID and name. It will be easier for us to associate the 2 points with you. All right, so of course, if you don't want to register, sure, let us know your student ID and name, and then it's easier for us to identify you. All right, so let me make sure about the poll here. Not finished? Finish all? Okay, that's good. So, just for this, for example, let me try to show you the history. You see? Actually, I can download the file and saw that, all right, maybe registration, that's fine. But, screen name here. If you don't want to show this, you just want to show the screen name. All right, so 1, it's okay. 2, here, this one. Next time you can change it because not easy. But we can use the ID, so that's fine. And here, fine. Fine. For example, Justin. Who is Justin? Perfect. Name and ID or exchange. And this one, okay. So at least one of these, we or TA can identify you. So Alina, right? So maybe, I'm not sure, but Alina next time still the ID.
Yes, I use a new one update.
Okay, sure. We'll check it later. So Adam, so maybe here you can try to have, for example, student ID.
Okay,
And
I will
Adam.
try it.
Yeah, next time. But this time we will try to identify you using our student list to check. No problem. So, someone like this, because I will dump the file, dump using the file and pass it to TA. If we have a TA, then it will collect the points for you. All right, so just for your reference, but normally I won't check in detail. I will have TA, so take it easy. If you don't think so, oh, okay, I just want to show the screen name. So that's why I point out at this, you need to let me or let us know the screen name. All right. So normally we have the result like this, and we won't check in detail, but we need to collect the points. So of course, we will use your screen name at least. All right. If you still want to show something here, you can scan and Let me know some of the answer here. Alright, that's it. So this is the poll, and it's important because this one actually is the activity of the course. Actually, you need to join and participate. Well, about the current discussion, we already have all these numbers that will vary. It's possible. But we expect to have the stable result, even they are not exactly the same. But we expect almost comparable results can be reached. Alright. So of course, results are functions of the input parameter. That's correct. For example, how about changing the input parameter? Of course, you won't have the same one. That's correct. And actually, we want to have a steady state characteristic. How to have the steady state characteristics? Here, I use service rate larger than arrival rate. Alright, and says inter-arrival time greater than mean service time. And then we will have the stable characteristic. And we have two. One using the sample size, and second one using time to start the simulation. And that's all. So currently we have two versions. And here, event and variable. Well, I'm not sure for the current era of maybe you want to use digital file. For me, maybe sometimes I want to use pencil and paper to draw something. And here, something like that one. Sometimes if you want to have some further thinking or critical thinking, you can draw something. For example, I want to use this one. It called the event diagram. We have an arrival event, we have a departure event, and we try to link these events. So arrival will link to departure, and the departure will link to itself, and arrival link to itself. And here we have the entry to the arrival. And this is a way to have the event diagram, arrival, departure. Maybe you have a question, why? No server. We have arrival, we have departure. Why? It won't be necessary to have a server. Because server will be associated with the arrival and also the departure. And then we think that's done. But maybe for you, no, I intend to have the specific processing for arrival, departure, server. That's fine, you can try. But finally think, okay, how to delineate the boundary between arrival, server, boundary between server and departure. Then you think, okay, maybe it's a problem for you. So finally, you will drop it. So it won't be necessary to have the state or the event of a server. No, it won't be necessary. All right, even we can have, we know, yeah, exactly, we can have arrival, we can have departure. And how about server? Yeah, it won't be necessary to include server and to include some possible event associated with server, because the event can be included by arrival, included by departure. So that's why I ask you if you can draw, and the thing about then you will know this one, it won't be necessary. All right, so this is an event diagram. And the next event diagram, yes, we try to have these, but enter service. Likewise, if you want to have this one, enter service, then it doesn't mean the server, but enter service. So we point out when to enter server or enter service. It's still okay. So arrival, server. That's fine. And finish, then depart. Depart, then try to get back to the server. So this one is okay. But not exactly the whole server. But point out when to enter the service facility. So this one okay as well. And the final one, we still borrow the first event diagram, but you see, we have the separate stat and simulation. So this one is version 2. And this one is version 1. So you can try this version, but it won't be necessary. However, this one possibly can be related to the original system, MN1, to have the arrival, to have not the whole server, but the starting service of the server. So you can have these. Well, that's it. So we already have a single server queuing system to serve as an example to start the simulation. Alright, even previously, maybe you are not familiar with the queuing system. At least you can know if you can think about this example. And we will use the example to have the extension. Alright, and that's it. Simulation of a single server queuing system is okay. And I already have the source code. You can try, and the next time I can bring the possible extension problem to all of you to have some discussion, maybe possibly. And so that you can have the programming assignment, it's soon to have a programming assignment, but we already have 4 weeks initially for this one. And maybe for next assignment, we will already have 3 weeks. Alright, so don't worry for the first one, 4 weeks. So of course, be familiar with the examples. And we will already have the problem, of course, based on the current example to have the extension. For example, we have the queuing delay. And how about finding the time stay in the system? I don't know. Currently, we have a queuing delay. And how about it should be sojourn? Sojourn delay says the total time spent in the system. So how to change the current source code to find the sojourn delay or the system time? System time including working in queue. And the time spent in the server. So this is the time spent in the system. We have a term, sojourn delay, or we have a term, system time. Alright, so how to have that one? You can think about that. And also you can have system length, including the size in the queue, system length. So you can think about this. At least you can think about this. Alright, so maybe you think, okay, is it too early to have the programming assignment? Maybe you think so, but then you have 4 weeks for the first programming assignment. 4. That says a month to be familiar with the example, to prepare the program, and finally get the result. And the policy, you can check the syllabus, of course. I will check accuracy, but it's your exercise, so it doesn't mean, okay, your answer is wrong, so 0. No, I will already have some maybe fundamental points plus accurate or not. So even you cannot have the accurate result, but still that you have enough points. All right. And of course, try to practice to make sure you can have the accurate enough result, and so that you can have high scores or maybe more points for the programming assignment. For programming assignment, I will already have 50 points for a problem. Maybe, they have 3 problems, then we will have 150 points. A total for the programming assignment, maybe 3 problems or maybe 2 problems only. Okay, any question?
We can do it in any programming language, right?
Yeah. But I will ask you to pass the source code using email, and I will check quickly. Sure. So that's why I mentioned you can have a podium, no problem. And send the source code to me. Of course, you change it to PDF. All right. It doesn't mean I will run the program. No, I want to check, and so of course it's easier for me to check PDF. And any questions else? After now, maybe not today, maybe next week I will bring the possible problem set and allow you to be familiar with the problem. And then you have one group discussion. All right, so we'll follow the problem set, but let me continue for the remaining. For this one, for your reference, in the task book we have the inventory system, but I've skipped it totally. And I just want to point out, for inventory system, maybe you can know the inventory system and try to think about the possible event diagram, and then you can have the simulation. So using the concept like this, that says, Professor, I'm not a guy of networking. Is it possible for me to have my own field? Yes. Similar to that one, and try to have the possible transformation, then you still can have the simulation. And in fact, I want to emphasize this again. For the simulation, is it possible to have a deterministic system so that it won't be necessary to have the random phenomenon? It's possible. For example, you just want to validate some of the proposed scheme, and without any uncertainty. Then you can have the validation for that strategy, that program, that algorithm. Even for that one, it is a simulation. But for the current discussion, we try to have the uncertainty. We try to have the random phenomenon. So that's why we gotta have the exponential interrupt time, exponential search time. But is that all? No. That's not all, so that's why we gotta have chapter 6, chapter 8, to gotta know if we don't want to use exponential simply, we need to have the other possible distributions. Can we have the way to generate those distributions to have those random variables? The answer is yes, so we will have more. But initially, we gotta have the really simple random system to have the current simulation for M1. As for the other possibility, you can have your own system. It's possible. Therefore, for your final report, we expect you can have the uncertainty to have the random system. But at least not the problem we consider in our assignment, no. Or maybe our current example, no. At least you need to have an advanced one, or maybe different one. All right. As for the score or the points you want to have, you can check our rubrics for the final project, or maybe for some description, so you can check. For our programming assignment, actually, in fact, I don't really have the rubrics, but I will really have some fundamental points and consider accuracy. They have more or less points. All right. And for this one, parallel or distributed simulation, or high level one. Actually, currently, it doesn't mean we have a high level or parallel one, but actually you can have the concept. And we don't mention this in D. We just let it have some idea. Is it possible to have the parallel discrete event simulation? Sure, it's possible. So then you need to have the concept, some concept, maybe multiple processes. Then you need to have the parallel one. And if so, then you can reduce the execution time because we want to make it faster. Or someone like, okay, currently we have a real processor, single processor and multiple processor. So you can shorten the time. All right, and so that you can have a logical processor, and so that you can have the way to show how it can work. But you have a processor, so you need to know this issue. The proper order or proper sequence to execute. So this is the issue. And to talk about the issue, actually, something like it is the synchronization in parallel simulation. We don't have the two terms just for reference, conservative and optimistic. And conservative, actually, we need to take care of any possible violation of causality constraint, because which one should be earlier and which one should be later. So this is the conservative one. And next one is called the optimistic approach, using the time warp mechanism. I say, okay, currently it should be the suitable one. But just for your reference, we can have the conservative one to avoid any violation of causality constraint. And optimistic says, okay, you can have your one, but that one for some of time warp mechanism, and so they still meet the time that says the causality constraint. So just some possible idea or issue to notice. And as for the details, maybe in the future, if indeed you want to use them, you can check. And of course, I should let you know these conservative here for reference, optimistic here, and warp. So actually, you will check the individual one later, and so that you know some of them, but just for reference, so it doesn't matter. So we have a multiple one, and actually, is it possible to have some federation, to have an advanced architecture? Here it says yes. So something like we have a multiple process, but we put it to the federate 1, 2, 3, and ask federate 1 to have some necessary processing, but should return. And so that you have the infrastructure to coordinate runtime. And so that you should check the order of processing suitable. Of course, because process individually, so which one fast, and then should be controlled by the infrastructure. All right. Even you have a somewhat complicated one, but this one can allow you to have the parallel processing. You see, parallel processing. Federal 1, 2, 3 can process it in parallel manner, and in a distributed federate to process. So of course we have parallel and distributed simulation. So this is the architecture, and we call this is the high level architecture. And of course the architecture here we won't touch in our course. We just let you know if necessary you can use this high level architecture to have the advanced simulation by using the concept of a parallel or distributed simulation. All right. As for the others, maybe today we cannot finish it, but next week we can continue. And next week for the remaining, perhaps we can go through a bit faster because there is some possible idea to avoid some of the problem, or maybe try to let it have the complete version to notice all the details of a simulation. But it's just a way to check. It doesn't mean we have the detailed source code, so it will be easier for us to go through quickly. And of course, next week we will let some advanced example in chapter 2. So of course we will check content in chapter 2. All right, that's all. And today the important one should be the example of M1 source code. So you can check it after classes. And before you go, let me ask you any questions for actually the code of M1 today.
I want to ask a question not related to the code. I'd like to ask what is the questions like in the examination? Like is it multiple choice or is non-question or calculate questions?
You mentioned about the question type in the exam, the final exam. Yeah, the final exam. Actually, not multiple choice problem. No. And related to the programming, possibly, but not asking to have a paragraph of the source code. No. Actually, the problem may be related to the later one. Maybe some to chapter 1 and 2. Most of them related to chapter 4, 6, and 8. And so then you will have the problem and try to answer directly, and not the programming type one, and not multiple one, and not true and false. Possibly can be the type of true or false. Yeah. Just part of them, not all of them. Yeah. So this is a possible type of the exam, final exam. And any other questions? If no, then that's it, and that's for your day. Maybe that you have 4 more minutes, but it's okay. Currently it's 11:24. I think you still have time to have your lunch. I think so. So that's why I readjust. And actually I should do something else. So that's why I readjust the time slot permanently. Permanently, not for a day, no. For all days within the semester. Okay, that's it and see you. Bye.